Hello everybody, this is Srikanth Dasari from Dasari Tools. Okay, so in this lesson, we are going to learn about how to program stack data structure in C++. Okay, so here I'm using Visual C++ 2005 Express Edition as an IDE to write code. Okay, so this is a very lightweight version. So if you want, you can know about this IDE. It's a long back released by Microsoft in the year 2005. The latest version currently is 2015 at the time of this recording. Okay, so ID should not matter to us. Whatever the ID we are using, the program is the main focus for us here. Okay, so I just launched the ID and already I have created a project under the name StackLab Prog or program, which is a shortcut for that, and I have a stack.cpp file here. Okay, so here I am putting all the header files. The most basic header file in C++ is going to be IO string. Okay. Uh, so now I'm just taking since C++ is a object-oriented programming language. Whatever the program you are intended to do, programs should be starting with the classes or classes concept here. Okay. So for that reason. So before that, we need to add this namespace, which is very similar. Okay, so now I'm defining a class named stack. Okay, so class stack. So inside the class stack, in the private section, we have this. We need to take some variables for our private variables for our stack data structure to in order to keep our excuse me, in order to keep our stack data structure, build our stack data structure. Okay, so first variable is going to be an array here. So before that, I need to do some things. So I need to define a macro also at the beginning. So hash define. So I have just defined a macro named as max here of 5, such that our stack consists of exactly 5 elements, or the upper limit of our elements in the stack is going to be 5 here. Okay, so next we need to take a variable top, which is very familiar when we are doing the programs in stack perspective. We need to track the topmost position of a stack, such that in order to delete or add elements, which is going to be done in one end, which is the basic principle of a stack, also known as LIFO. Okay, so in the public section, so I am defining some very important methods here. The first member function is going to be a constructor here. So as you all know that constructor is it's a name which has the name of the constructor is going to be the name of the class. So for that reason, we have taken a stack here, stack constructor, or the constructor for this class, which is going to be the stack. In the constructor, I am just initializing the top value to -1, such that which signifies that the stack is empty. Okay, so next I'm defining this excuse me, I'm defining this push method here. So push method, so before you are pushing any element into the stack, you need to check whether so it consists of whether there is any room to enter any elements inside the stack. So we need to check that according to the algorithm. So if top is equal to max -1 is the condition. So if at all it's true, then there is no room, which means that the topmost position is one less than the maximum size of the stack or a macro, such that since the indexing of an array starts from 0 in C, so that we can't insert. That means that the topmost element, if the top is equal to the maximum range of an array, then we can't element such that which signifies that our stack is full at that stage here. Okay, so you can have a small message saying that, or else you need to use endl, which is a good practice while doing programs in C++. You can say you can have a message here: the stack is full. Okay, so there is no room for entering elements. So if at all that is not the case, So then you can so take an item variable. Okay, so you can take an item variable and you can scan the element //t, or else you can put the endl statement, endl operator. Okay, so you can say so enter an element, to be pushed inside the stack. Okay, so now let's take a cin statement to grab the input from the keyboard. And then what we are going to do is so we need to increment the position of the top, and uh, at that position we need to insert our element here. Okay, so the name of our array here we have taken is arr. So arr of top is equal to item. Okay, so this is the push definition here. Okay, so next we are going to define the pop method. So another important operation which we are going to perform on stack operation. Okay, so before the popping an element from the stack, we need to check whether whether there are any elements inside the existing inside the stack data structure. So if there were no elements inside the stack data structure, then there is no case in point of popping an element from the stack. Okay, so to check that, let's say if top is equal to -1, so then you can have another message such that so you can say endl the stack is empty. The stack is empty. Okay, the stack is empty, or stack underflow, or whatever the or what sort of message you want, you can put that here. Okay, so or else if that is not the case, and else condition, what you're going to write is let's say you can have a message like the elements in the stack. Let's put a handle. The elements in the stack are as follows. So I'm just putting a splashing here, excuse me. Okay, so here we need to take a for loop here. So for I, int I is equal to topmost position, and I greater than or equal to 0, and we need to decrement the top. We need to decrement the top, and now we are just putting that elements, or displaying those elements of the stack starting from the top here. Okay, so the name of the stack array is stack arr of I. Okay, so this is the case of which we have to. This is a way order or which we need to implement the popping algorithm inside a stack here. Okay, so so the one last thing which we are going to define here is the display method here. Okay, so void display. Okay, so void display. So void display. So how to display? Also before displaying elements, so we need to check whether there are any elements inside the stack here. Okay, so for that reason, again, I'm checking whether there exist any elements. If top is equal to -1, which signifies that the stack is empty. So that's what we are going to have a message here. So cout endl. The stack is empty. Okay. So in else condition, we're taking a for loop here. So for I is equal to top. So I is equal to top. So I greater than or equal to 0. I minus minus. Okay. So okay. So cout endl. Stack error of here. Okay. So and then we have just done a small mistake here. So we don't need a for loop inside to pop thing. So we have missed the entire logic here. Okay. So I'm just wrote a small mistake here. So in the pop section, the algorithm is going to be like this: int item. So we need to take an item variable. So first we need to pop out the element from the stack, which means that place the topmost element of the stack inside this item variable here. Okay, so place the topmost element of the stack inside the item variable, and then we need to decrement our top variable. Okay, since we have just popped out an element, so there is no case in point of having that position or making our top to point to that position. Okay, so and the last you can have a cout message here saying that uh, the popped element is so and so. Okay, the popped element is equal to item. Okay, excuse me. So that's in that way we have just finished coding all the functions or methods, or sorry, member functions. So now what we're going to do is I'm just putting a main method here, and then after putting the main method I'm just taking a variable of the class. I'm just saying a stack s1. So s1 dot push. Okay, so if I call the push function 10 times or so, so if you call the push function of 5 times or so, okay, so first, so I'm just formatting the source. Okay, so 1 2 3 4 5. Okay, so when you call the sixth time, so calling this push function sixth time, which means that you need to display the message stack overflow. Okay, so if you run the program, you'll have a better understanding here. Okay, so before that, let me put some things. Scene.sync and scene.get. Okay, so let me run the program. We have an error. Silly mistake I have done. I haven't declared the variable. So run the program. So here, if you observe, as soon as I run the program, it's asking me to enter all the elements. Since we have called the pop function, it's asking me to enter some elements inside the stack. Okay, so I'm just entering some elements: 1 2 3 4 and 5. Stack is fully okay. So if you call the sixth time, as soon as you call the push function the sixth time, okay, so if you display, so before that let's display also. Let's use the display function s1.display. Okay, so now if you run the program once again, just coming out of the output here. Okay, again I'm just entering all the elements in the stack. Okay, so if you observe here, as soon as we have entered the 5 elements, which were 1 2 3 4 and 5, we have after that we have just displayed. So if you come back to your IDE, so here we have used the display function. So that's the reason we have all the elements in the stack got displayed here. And then as soon as if you're trying to call the push method after the sixth time, so what happens is you get the message the stack is full here. Okay, the stack is full here. Okay. So in that way, you can implement the stack data structure inside C++ environment. Okay, so to revise once again, what we have done here is, so here we have taken a class named of stack, and inside that class stack we have two private variables. Let me put a comment here. So private members, so private members of the stack class. Okay, so public member functions. Okay, so and in the public section we have first defined a constructor. We have defined a constructor to initialize the stack data members. Push, and we have a member function. So this is the member function. Push to add elements, to add elements into the stack. Okay, and here we have the member function pop. So member function pop uh, to remove elements so from the stack. Okay, so we have the one last member function, which is display. So member function display to print the contents of the stack. Okay, so we have total three member functions and total four, including the constructor here. And then we have just declared a stack variable, object for the stack class here. And then we have called the push function or push member function for 5 times, 5 consecutive times. And we have just using the display member function. Using the display member function, we have just displayed the contents of the stack. And as soon as we are trying to call the push function for the sixth time, we get the message here, which is stack is full. Okay, so if you run the program for the one last time, so if you enter some contents like 5, 4, 3, 2, 1, and so on and so forth, and you get all the elements displayed here in the reverse order, since the stack is last in first out data structure. And according to our calling order of our functions, as soon as we try to call the push function for the last time, we get this message, which is stack is full. Okay, so this is the basic stuff about stack programming stack data structure in C++. So hope it helped you. So feel free to comment on the tutorial, and don't forget to subscribe to the channel and hit a like button at the end. Okay, so see you in the next lesson. Goodbye.